Sign up for it. What? Oh, for the concert?
Yeah, let's we do it morning time.
Yeah. Do it in the morning slot. Freshie. I heard. Legendary move. I'm so excited because I have so much work to do that I don't have to do anymore.
Okay.
What is it? It's gonna be a grind.
Yeah, my priority was 250 pages. But it's the one I had to read because it's the autobiography, so I'm really gonna pick.
Oh, he might do this at like. You wrote 5 books about himself? Well, it's like the 5 different periods.
Sounds like a narcissist to me.
That's a lot to say. You're all sitting in the back. Oh, okay.
What do you think is more narcissistic? A memoir or an autobiography? I think a memoir.
I think it's got to be an epic.
Oh yeah, an epic. Wait, can you write your own epic?
Like, come on, Odysseus named the darn book after himself.
No, Homer wrote that.
I know.
Oh, okay. I'm a little bit slow today, Mr. Bergeron. It's been a long morning.
It's been a long everything.
That's the epic.
All right, folks, we'll go ahead and get started. Thank you for being here. Welcome, no matter where you are. Plan for the day, since it always seems like, especially when we go 3 meetings 1 week, 2 meetings the other week, that it's been a while since I've seen folks and that we've worked with biology. So our plan of attack for the day, I've got a brief check-in for you. Really focusing on the highs and lows of the past week. I know for me that sometimes my negativity bias gets kicked into overdrive and I have to intentionally focus on what's going well in my life in order to ground myself in the present moment. So I thought that might be helpful for you as well. But then afterwards, I want to do a brief making connections activity with you as we think back to what we were talking about last time. And then about 20 minutes to work independently, asynchronously on some different online activities that will give you a chance to either review or even dig a little bit deeper into the structure and function of proteins. So some different opportunities there that are available to you. If we have time at the end, we can look at a classic example of how protein structure contributes to a specific human disorder. It's sickle cell disorder. You may have heard of that before in other classes. But that's not required. It's just an example of how protein structure is relevant to biology. So that is the plan for the day. Before we get started though, questions, comments, epic poems for the good of the class. Okay. All right then. Well, again, the check-in for today, it's called highs and lows. It's really simple. As you think back over these last few days, over the last week, what's been going well for you? And what hasn't been going well for you? It's always okay to acknowledge the negative without getting overwhelmed or lost in it. Take a moment. What's your high? What are your lows? Or what are your highs and what are your lows over the last few days? Um, next time we meet, I've got a lab activity set up, whether you're going to be here in person or you're going to be learning from home. There's a virtual equivalent for this experience, but I've been working with it and practicing with it for the last few days, and I've got it down to a trial of 4 minutes. So I thought, given the fact that we only have 45 minutes together every other day, getting a trial down to where you can do multiple trials of this experiment, regardless of your setting, would be really important. So that's one of my highs. My lows, well, my wife's had a fever for about 5 days now. And the first test was negative. You can imagine what this test is for. Her flu is negative, which is encouraging. She went for another test today to ensure that wasn't a false negative in respect to coronavirus last week. So we'll see. But it's like this drumbeat in your head and in your heart, you know, that just stays with you. So those have been my highs and lows over the last few days. Let's scroll down here to the bottom. Yeah. Homework. Why is there so much homework? What are we doing? All of my work done. Yeah, but hopefully taking some time to enjoy yourself. Everything is the low, coffee is the high. I'm hoping it's good coffee. Yeah, for sure. What is the deal? What is the deal with English? Yes. Holiday decorations are great, aren't they? Well, hopefully the Christmas mood will set in over these next few days. Finals. No final in this class, remember. There's one thing that came out of another class that I wanted to share with you folks, just as we kind of scroll up in reverse chronological order. It hit me like a bag of hammers when I saw it this morning. See if I can find it again. Is that a bloody check mark? Or is it a check mark wearing a handkerchief? That's not the one I was trying to show you. It was this one. You know, the level of vulnerability that this particular student, one of your peers, right? Somebody in this building and in this class was willing to share with classmates this morning is remarkable. And it helps put everything in perspective, right? Yeah, English sucks, homework sucks. And then there's other things in life which have great meaning and significance, right? And even then, sometimes we have to take those moments to refocus on what's going well, not to ignore the fact that there are huge, potentially and real negative things going on in our lives, but that there's other things to consider as well. So yeah, I wanted to share that with you folks as well, even though it's not somebody in this class, it's somebody in a different class today. Hit me pretty hard. So maybe it did the same for you. All right. Well, it's always weird to see something like that this morning, like I did for the first time, and then share that with you, like I did just a moment ago for the second time today, and then say, let's go learn biology. And yet, what else are we here for, right? It was even interesting. That particular student who shared that, I private chatted in the moment and said, you know what, get out of here. Go take time for yourself. And the student said, no, my dad wants me to be here. And it's just like, wow. Wow. And the student stayed the whole time. So maybe that's our motivation today. That even with something so big going on in your life, you still tried to be there. So, in perhaps the most awkward transition ever, as we think back to what we were looking at last week, there were two major takeaways. I'm hoping you remember them. That both the sequence and the composition of amino acids within a polypeptide influence the structure, the tertiary structure of a protein molecule. If you think about those two big ideas, what might you put in the middle? Drawing some words that connect those two ideas to one another. Take a minute or two here and write your thoughts, write your connection. All right. Okay, I'm going to scroll to the bottom here to find your class. Yeah, changes elicit changes, right? Both contribute to the structure. I don't know what that is. Yeah, there's something to do with the amino acids and how they react to the solution around them. There was a question that we considered on Thursday about moving from a polar to a non-polar environment and how the protein might change. Yeah, there's something to do with the net charges of each amino acid, for sure. There, that's what I'm hoping to see, right? The tertiary structure is determined by the arrangement of R groups or the side groups of each amino acid. Remember, that's the part of the amino acid that makes everyone different, right? And some are basic, right? They have a positive charge, and some are negative. They have acidic properties. Some are polar, some are non-polar. And of course, you need to memorize all the names and all the structures and all the properties in order to be successful, because that's what matters. No, that's not what matters. What matters is that when we think about the model that we were playing with, whether you were playing with it in person or, a virtual model that I tried to create for the folks at home, those push pins that had different colors represented different amino acid side chains. And based on some really simple rules of chemistry, we know that those side chains could attract one another, right? That the polar side chains tended to interact with water on the surface of the protein, maybe even with each other. While the non-polar side chains, if that protein was trying to fold in water or stay folded in water, would make their way to the inside of that protein. Yeah, for sure. Side groups, hydrophobic, attract, repel. Enzyme, that's where we're going next, right? When we get together again on Wednesday, our lab, our next in-person / virtual lab, is going to be all about a particular type of protein, an enzyme. Yeah, interactions. Good. So again, major takeaway would be, that the side chains of these different amino acids are contributing to the way that polypeptide will fold into a protein. And if I change either the sequence or the composition of those amino acids that are part of a larger polypeptide, then I'm likely going to also change the three-dimensional structure of the protein. Alrighty. Well, this is where I wanted to give you some time to work independently and for me to support you if I can along the way. I really, I don't want homework to be work that you do at home with no feedback. If we can switch this, right, and the lesson can take place as part of a video, and then we can do the homework during class time, where I can support you if you have questions. It just seems like a much better use of our time in general, but especially now. So we just did our making connections activity. Some options, if you feel like you need to kind of start from the beginning with protein structure, I would recommend that PLIX activity. If you want to dig deeper into protein structure and function, I would encourage you to take a look at homework 31, which if you remember from the text last week, is not actually homework, right? It's an optional assignment. Do the parts that you think are most relevant to your learning. If you feel like you're ready to kind of assess your understanding, there are some AP questions, both free response and multiple choice, that you might want to take a look at. So I'll leave that up to you to decide what's best for you. But let's take about 20 minutes. We'll reconvene at 12:40, and we can certainly go over any of the answers to the practice questions or just answer any questions that you might have in general. But if you have questions along the way, please, please, please don't struggle in silence. Ask for help. Okay? But I will come back and meet with everybody in about 20 minutes. About 10 minutes left. It's awfully quiet. Hope that means everything's going well. Couple more minutes. Try to find a good spot to pause, to wrap up your thinking, to wrap up your answer. Right. Would it be helpful to go over any of the practice questions? Seeing one head nod. Can I get some feedback? Got to have a preference, right? Or no? Okay. Okay. So why don't we do this? Why don't we, I'll take out of student mode here, so we're all looking at the same thing at the same time. Let's start with the multiple choice question. That probably connects best to what we were doing in class last time anyway. If it helps, I can draw the structure of cysteine. I don't know if you need it to answer the question. Try to get an answer in. It's okay if you're not sure. This isn't for points or grade. For the sake of time, you can take a look real quick. Good, good. Specifically, you don't even have to know anything about the side chain for cysteine. I can draw it. You could memorize it, but it's not really going to help you to answer the question, right? It's getting at really how these interactions between side chains can act to stabilize the tertiary, the three-dimensional structure of a protein. And if there are more of them present, more of these particular side chain, the prediction, the expectation would be that that's going to allow for more interactions to take place and for the stability of the overall molecule to increase. And in the case of cysteine, It's one of those side chains, really the only side chain that can form covalent bonds between side chains, specifically other cysteine side chains. So yeah, if I increase the number of covalent bonds that are forming as that polypeptide folds into its final three-dimensional shape, I'm going to have a more stable structure, even in really extreme environments, really alkaline or really acidic environments, or really high temperature environments for that matter. So good, that's awesome. Can erase my drawing. Let's try one of the free response questions. Try this one. This one's probably a little bit more straightforward than the other one, just in terms of the good use of our time. Take a moment, even with about 5 minutes to go. Take 2 or 3 minutes and put together an answer to this question. Again, we get better as we practice. Right? You've watched Edpuzzle videos, primary, secondary, tertiary, quaternary structure. Those terms should not be completely unfamiliar to you. But if you feel uncertain with them, maybe this is the little push that you need to go and either watch these videos again, or watch one of the videos again, or even dig a little bit deeper into one of the activities that you could have chosen to work with in class today. The click-clack of keys here in the classroom has come to a close. So if we just take these last few minutes and talk about a potential answer, when a polypeptide folds into a protein, there are 4 levels of protein structure that are relevant to us as biologists. The primary structure is simply what you were trying to model in class last time. It's the sequence, it's the composition of amino acids within that polypeptide. So with those push pins, it's the order and the types of amino acids that are part of the polypeptide. And certainly, if I swap out one amino acid for another, I'm going to affect the primary structure. There's no way around that. So that one's going to change. Secondary structure is probably the hardest of them all to consider, because the secondary structure, so I can pull out a model here and show it to two different groups of people at the same time. Secondary structure really comes in 2 different forms. There are these pleated sheets, these beta sheets, where parts of the polypeptide fold back on themselves. Oh goodness. You guys all right? I know, attention is hard. And then there's also alpha helices, which I'm not sure I can do very well. The little springs that form as the polypeptide folds. But none of those regions actually require interactions between side groups. So I can swap out the side groups all day long. Chances are I'm not going to influence the formation of any secondary structures. Okay, so throw that one out in terms of there being a change. Tertiary structure, it's a big, I don't know, right? Probably, if I switch out one amino acid for another, in this case, a positively charged side chain, right? For a negatively charged side chain, And I think back to what we tried to model last week. Well, if positives and negatives attract each other, if positively and negatively charged side chains attract each other as the tertiary structure forms, and I disrupt the ability for those interactions to form, probably going to disrupt the way that that protein folds. But there's always a chance that that particular side chain isn't actually interacting with an oppositely charged side chain. Okay, so it's not one of those answers that is hard and fast. It's this, right? It's possible that it has an effect, but it's also possible that it doesn't have an effect. Either of those responses would earn you full credit as long as you are clarifying your position. All right. So primary, secondary, tertiary, quaternary. Recall, quaternary structure is just when two or more proteins are interacting with each other. And here's another big maybe, right? If that particular amino acid, the basic amino acid, was forming a bond, an ionic bond, with a neighboring protein, right? With a protein that was interacting with it, then yeah, if I get rid of that interaction, the overall quaternary structure could be disrupted. But if it's not involved, if it's just a polar amino acid, a charged amino acid sitting out on the surface of my protein, then maybe it's not going to have an effect. Right? I really don't know enough about the particular protein to be able to say definitively what the effect could be. So with that flexibility comes two different possible answers, both of which are equally valid. Right? So I hope that helps. So anything coming up? We've got one more practice question we can try before we wrap up. Is any or all of this bringing up questions for you folks, whether you're at home or here in the classroom? And I must be really good at my job. Or terrible. All right, well, let's do one more then. It's probably the most challenging. That's the multiple choice. This actually comes right out of the, oh, sorry. Maybe we'll do this one next time then. I forgot. It's not 12:55, it's 12:50. All right, we're fine. That's good. We got to where we needed to go. Lost track of time.
Thank you, Mr. Bergeron.
All right, I'll see you folks in a couple days. That last question was our exit slip, folks. You're welcome to sign off.